I spent 7 years prior to that working for a large Swiss financial firm on their cloud adoption program. So in that, one of the things I've worked on over the last 6 or 7 years was this concept of confidential computing. And so what I want to do here is have a look at getting rid of that bit off the slide for a start. We'll have a look at what confidential compute really is. Clicker works. I'll use my mouse instead. So we'll have a quick look at what confidential compute is, because there's a lot of, I think there's kind of a lot of confusion or mystery or misunderstanding around what confidential compute is. We'll have I've swapped around the order slightly. So given I imagine the audience here is one of the more fairly technical audiences versus some of those we usually present to, we'll have a look at some of the technical underpinnings for what provides confidential compute in the Azure platform. And then I've got a whole bunch of detail on use cases, and I have some live no safety net demos, which hopefully will work. They're working earlier. So I use this diagram quite a lot, and apologies to anybody who's worked with me in the past. I always like to try and represent Azure as a kind of stack of technologies put together. So really kind of going from the bottom up. The bottom is essentially, table stakes of an engagement with Microsoft. So it's the contractual commitments that Microsoft make around legal elements, the data privacy commitments that are made. All of these things are fairly transparently laid out in the terms of use. All the 900-page documents that Microsoft produce around these topics. But there are ways of boiling that down to a much simpler version, which are really there around setting people's expectations around how Microsoft handle and deal with your data in the platform. We then come up to the layer below, if I use the laser pointer. So you've got this layer here. So I kind of group them together, which is essentially the control plane and all the physical elements of the platform. So data center, storage, compute, network, all of the things that make up the Azure platform. So these are the things that Microsoft essentially operate on your behalf. And certainly for those of you that are from a kind of regulated industry, all of the things that you would typically have to do in terms of providing evidence around how you manage things like joiner mover lever, or how you might deal with physical security of buildings, these are essentially elements that Microsoft manage on your behalf. So it's a kind of combination of control plane and physical elements of the platform. They're all independently audited. For anybody who doesn't have access to Azure Trust Center, if you speak to your account team, you can quite easily get access to that. That's where you can see all of the independent audit reports. And like I say, for anybody in a regulated industry, you have to go through these audit cycles every year of proving to your regulators how you operate elements of your platform. Microsoft have to do exactly the same thing. And that's all transparently published through Azure Trust Center. So things like FedRAMP, SOC 2 reports, all of those accreditations are there. And that really helps you understand how Microsoft manage the elements of the technology and the operational side of the platform that they're responsible for. The bit that people are probably more familiar with are things like what we call tenant controls here. So this is where you have your own tenancy within Azure. And really, this is kind of bounded to Azure Active Directory and subscription structures in the real world. This is where you take all the tooling that Microsoft provides, so things like role-based access control, Azure log analytics, Azure policy, all those elements that really shape how you as an organization want to use the Azure platform. Now, taken as a whole, those elements there already provide a really kind of good defense in depth strategy, right? And to date, that's really what Azure has had, and is fairly equivalent to actually most of the other hyperscalers. So, for anybody to get access to the lower levels of the Azure platform, you're looking at what we typically call a cascading control failure. One or more of these elements would have to fail for a bad actor to have access to customer data or being able to get in some kind of unauthorized manner. Azure Confidential Computing technically really lives in the kind of server and storage plane, but I like to kind of visualize it like this. So confidential computing is around providing protection of data in use. Okay, and there's really two elements of this. There's protection of data in use through encryption, which is combined with assurance. Okay, and assurance in technical terms is really put together through what we call an attestation service, which we'll look at in a moment. But if you look, if I come back in a second, sorry, I will dive around this deck in a little bit. And if you've got questions, more than happy to take them as we go. So we've always done data at rest protection with encryption. Even in the early days of Azure, storage was encrypted. In the early days, it was always done using kind of Microsoft managed keys. You'll have seen over the last, certainly the last 3 or 4 years, customer managed key has become fairly ubiquitous across the Azure platform. There are still, a few services that are kind of catching up in that space, and that's the difference between Microsoft managing your encryption keys or you as the customer being fully in control of the encryption keys and rolling of them. And this is a cloud service, right? So data in transit is one of these things that's always been built in from day one. If you think this has always been fairly transparent on the internet, right? All of the major search engines fairly transparently switch from everything being in clear text to being protected by TLS by default. So this provides kind of end-to-end encryption of data whilst it's moving around the network and the various endpoints by encrypting it whilst it's in transit. And that's, that's been the kind of state of the world or state of the art up until fairly recently. It's always been really technically challenging to encrypt and protect data whilst it's in use. I mean, if you just think about the physics of what's going on here, you're talking about stuff that's happening inside the CPU. Up until now, you've kind of dealt with kind of logical segregation and enforced through RBAC and various other technologies to prevent certain processes attaching to certain things or certain networks talking to other networks. Confidential compute is really taking advantage of some of the kind of silicon level innovations that have gone into the chips themselves over the last few years. So if you look at the work that Intel have done in the early days with their SGX product, through to AMD now with their EPYC series of processors, and also in the kind of GPU space, where now we're able to leverage features on the CPU dies themselves to embed security processors, encryption processes, and essentially do it transparently. One of the main reasons this is an important technology, and I'll flip back to one other slide to explain this from a slightly different angle in a second, but if you think about the typical threats that we consider, okay, so insider threat. So this is one of your own internal administrators with malintent trying to access data that they're not entitled to get to, right? So today, your only real mechanism of defense for doing that in traditional platforms is through RBAC, supervision, logging to be able to detect those kind of things. Confidential compute gives you the ability to technically lock out even administrators, so people who have to have access from the top of the tree, in a kind of RBAC terms. It gives you the ability to technically lock them out of data through encryption to prevent them abusing their administrative permissions. I think it's fairly safe to say Azure is obviously a very kind of fairly mature platform, very well stacked up in terms of design, but it always operates from an assumed breach position, right? If I stood here and say, Azure's perfect, there are no bugs, right? That's a fairly naive position to take, because there is always the scope for those kind of things to do. So through that defense in depth strategy, confidential computing gives you another layer to mitigate things. For example, if someone were able to obtain access to one of the Azure hypervisor hosts themselves, confidential compute gives the ability to protect against those attackers having access to customer data. Also opens up some new scenarios for third-party data collaboration. For anybody who's ever had to do a kind of clean room solution or something where you are having to take data from multiple parties, analyze it in the whole, do some kind of collaborative work, especially if it's got sensitive data. You might take, account data from one place, credit card data from somewhere else, merchant patterns from a retailer. That aggregate data set in itself contains a lot of highly sensitive, personally identifiable information. And because it's aggregated together, it becomes even worse in terms of scope of breach. Confidential compute kind of gives you some technologies where you're able to put all that data into an enclave, work on it without sharing that data with everybody. And just kind of talk about why, or some of the drivers behind this. Okay, yeah, it's a cool technology. Don't get I'm a technology person. I quite like the nuts and bolts of this thing, and there's some really clever technical things that this enables. But in terms of the reasons why I think this is important, and I think this is going to be something that really becomes default table stakes for the cloud in future. So privacy is the first part of this, right? And if I were to make a fairly blunt commercial statement here, Azure doesn't make money out of your data, right? Azure does not take and analyze your data and monetize the fact that you're speaking to an other company and try and sell you a credit card deal off the back of it. And conversely, customers don't want Azure to see their data. You have various regulations and commitments to your own customers that you don't. You limit people who have access to that data to the entire smallest place. So that privacy is the right thing to do. If we wanted to take a slightly wider view, morally, that's the right thing to do. But in a purely commercial sense as well, it helps Azure get into more places, more industries, right? If Azure can't start to provide those elevated levels of protection, that starts to get really challenging for financial services, for example. And on that, it's certainly in my previous role, I spent a lot of time dealing with the various large financial services regulators of the world. What I saw there over the last 6 years is it really changed from being hey, we read this white paper about this stuff. Have you heard of it? Kind of discussion. We say yes. We as the customer, we've heard of it. Yeah, but it's not quite ready for prime time yet. That discussion is evolving across time, and where that will eventually end up is the regulators going, we've seen this technology. Have you thought about using it? It looks like a really good solution for privacy, and you're a financial services company or a healthcare company. This is core to what you do, and that is going to be trending towards the more stringent questions from the regulator, which is, why are you not using this technology? And you come from the position of having to say, well, we looked at it, it's really interesting, to this is now mainstream, why are you not adopting it? I mean, can you imagine having that discussion today with a regulator who said, are you encrypting your data? Why are you not encrypting your data? That's where that's going to get. And as the technology matures over time, that's going to filter down through the various industries across time from those regulators, and that will really drive the kind of default position across all those cloud platforms. I think I kind of touched customer trust. We kind of trust. That's really the point of Azure trying to get into more industries and customers being comfortable to host their data in there. And this untrusted collaboration is what I talked about with the kind of multi-party data collaboration type solutions. So there is a common definition from the Confidential Compute Consortium of what confidential computing is. Okay, and we're really aligned with that definition, which is protection of data in use using a hardware-based and a tested, trusted execution environment. I have to read that because the wording changed fairly slightly. And the important piece there is that hardware-based. Okay, and we'll look at why that's important in a moment. So kind of covered that. So the Confidential Computing Consortium is an industry body, right? This is not something that Microsoft have cooked up. This is a body you'll see on this, on the NASCAR slide here. There are various other parties on it, even people who technically are competitors of Microsoft in the kind of hyperscale and cloud environment. And the reason this is important is because we want to make sure that everybody has the same definition. I mean, you'll have all seen it. Some new technology comes out. And everybody suddenly claims they're doing it, right? And they're able to do that because it's kind of easy to say, yeah, we do that, right? And I think everybody kind of signs up to the kind of industry view that, hardware-based protection out of this is really what gives you the best level of protection for a confidential compute platform. Okay, you're not relying on purely software implementations from one vendor. You're essentially talking about a combination of technologies in a stack with keys and protections that aren't necessarily accessible by the cloud provider. We kind of talked about this. So again, this is that kind of piece around taking data from multiple places, doing things like machine learning. Yeah. Yeah. Correct. Yeah. So I mean, the reason for this is, I mean, it's not. Obviously, I work for Microsoft now, so I don't necessarily want to stand here and bash AWS. AWS do, really good kind of engineering. They have a really cool cloud platform. I think the difference for us and the way we've aligned that platform is that it's if you think about the way the AWS Nitro stack is designed, it's really around, and there's a lot of kind of independent viewpoints on this as well. The AWS ultimately engineer the software that makes the access control decision. around that. And it's different when you're using a solution that's based around purely using the hardware to do that. In this case, right, it's a combination actually between Microsoft and Intel or AMD or even NVIDIA, right? So you're essentially, you have a watcher of the watcher. And as you'll see over the next couple of years with things like, there's Project Amber, for example, where you're even potentially some discussion of other external parties acting as the kind of attestation and oversight for this to provide a kind of a third leg of that kind of independent verification. And if you think about the other way around, right, obviously the Nitro chips are produced and designed in-house by AWS, and obviously they have a fab manufacture them. Whereas this is really taking standard technologies from Intel and AMD, etc. Okay, so if we were to look, and I think this is probably where more people are interested, right? If we were to look at really the technical bits and pieces of what this is. So confidential compute is really based around the concept of a trusted execution environment. Okay, and this is really sometimes interchangeably used in enclave, which is essentially, if you think of it as a black box, right? This is an area on the CPU within memory that is essentially fenced off and inaccessible from outside it. So it isolates whatever code by encrypting CPU registers. It encrypts data that's stored in memory whilst it's being executed to prevent anything on the outside having access to it. Back to this in a second. That slide shouldn't be there. So this is really what we're talking about here. So I know everybody says zero trust and everybody's really bored of it, right? But it is that principle, and it's around providing properties and proofs for all of this. So on this diagram here, this blue box is the trusted execution environment. So this is where either your bits of code, in the case of SGX, or your entire virtual machine live, okay? And you go through a various cycle to attest, release secrets and keys before that VM can even be started. But the important bit for this diagram is host OS, hypervisor, BIOS, and things that sit down here at this tier. So these are the elements that are controlled by Microsoft, are outside of what we call the trusted compute base. So you as the customer, you trust what's inside this VM. You don't necessarily trust this. And it's why it's important, because it plays back to the zero trust discussion. And if you think back to what I said about that kind of stack of controls, if you had a really bad day and you fail things like access control, someone's able to invoke just-in-time access, for example, on the hypervisor, someone's able to even get to it in network point of view. If someone has access down here and they dump the memory contents of your virtual machine, all they're able to see is encrypted content. Okay, so they can't get to it in the clear. The only place data is processed in the clear is inside that trusted execution environment. Now, depending on which technology, on that, and you'll see at the bottom, so Intel and AMD and NVIDIA actually as well with this. This is where that root of trust comes. So you trust the CPU is the CPU it says it is. All of the system security processes are baked into the silicon that come from that hardware vendor. So it's outside even the control of the cloud provider, or Azure in this case. And that is linked and tied to, which is what the padlock's intended to represent, is that the cryptographic proofs that come with the chip are tied to that trusted execution environment. Now, today, in GA terms, okay, there are really two ways of doing confidential compute for mainstream. Okay, so the Intel offering on the left-hand side is based on their software guard extensions, or SGX technology. Okay, this is the one that's been around the longest. Has a fairly high bar of adoption because you need to code your application specifically to be able to consume it. Okay, so if you look at this, it uses an app-based enclave here. So what this really means is, if you imagine this is one CPU, you have to code your application so that specific bits of it reside in the enclave. So if you had an application and you wanted to deal with things like credit card numbers or people's home addresses, PII, you have to compile and write your application using a specific SDK to ensure those bits are only processed inside the enclave. And it's quite complicated architecture, and there are a whole bunch of ways to have. You can have enclaves, trust enclaves, and you can build them together in almost a kind of a mesh of things that work together. And that's what we've had for a fairly long time, right? So SGX has been around for a number of years. The AMD offering on the other side takes advantage of some of the capabilities of their new EPYC processors. This takes a slightly different model. It allows you to take an entire virtual machine and stick it inside of a trusted execution environment. Yeah, and they're fairly big, right? These go up to, I think, 768 gigs of RAM last time I looked, and 96 processors. So these aren't weedy machines. And the advantage with this is it means that you can just take a VM, right? This is a VM, you can install whatever you like inside it, and you still benefit from that same level of protection from the hypervisor. Okay, even if someone's able to access the hypervisor here, again, failing a stack of control failures to be able to do it in the first place, but all they can dump is encrypted contents of that VM. One thing that is important to point out with this as well is that because that's a virtual machine, everything inside this blue box essentially is processed in clear text, okay, or however you choose to process it. It's from the outside that the contents are encrypted. If this is a VM and you've got root access to the VM or an administrator user on a Windows box, you're able to see all that data. Okay, whereas if you're doing that on the SGX model on the left-hand side, even if you're the root user here, those processes you can only see with encrypted contents. And if you look on the Microsoft Mechanics blog, there's a set of YouTube videos for this. There's a really good demo of how they do this with SQL, for example. SQL has the capability to use SGX, so you can ensure that certain elements and tables are held encrypted, and even if you've got root or admin access onto the underlying SQL server, you can't see that stuff in plain text. Now, it's not just for traditional CPUs, right? This is also bridging out, and this is still fairly new. Some of this is in limited preview at the moment, but with GPUs, they're starting to provide the same capabilities. So we're doing a lot of work with NVIDIA to do this, and I don't think anybody could have missed ChatGPT and all of the grand things that are going on in that space. That's a really interesting challenge for confidentiality and privacy, which is really where we look to see confidential computing starting to enhance the privacy of things in those spaces, because the IP and a lot of those kind of ML models is around the models and the weights and the tuning that go with it. You can use confidential compute to ensure that that's only ever processed inside a secure enclave. So, and then the second part of this I talked about, it isn't just about memory encryption and CPU encryption of things going on. We tied back to this hardware root of trust, which is what we use as the base for the attestation services. So this is really a way of you as the customer being able to verify that your workload is executing on the correct type of hardware. Okay, so to play this back in kind of practical terms, to give you a real example of what this is. You can always see from the Azure control plane what type of SKU you're deployed on, so you know what type of hardware your Azure is telling you. What the attestation really gives you is a way of viewing the cryptographic data that the system security processor provides back. It gives you a degree of protection and assurance that nobody in the back end of Azure, again, if you go back to that kind of malicious Azure operator or cloud operator scenario, you're gaining a hard guarantee that that workload hasn't been moved onto a general purpose CPU, for example, where it doesn't offer the same level of protection. And I've got a demonstration of how this works later on that I'll show you. Another point that's important into this is how attestation is used when you start a virtual machine or a process for this. Okay, so your VM by default, it sits there as a kind of an encrypted blob in the storage. When you try and start your VM, which I'll do a bad job of kind of following the flow here, but essentially the trusted execution host here has a client. The client calls the attestation service. The attestation service will provide back the evidence to the trusted execution environment, in this case, the system security processor, of the type of hardware that it's running on. It uses that attestation service to talk to the key management load. I've proven it's running where it should be. Now give me the goods. And what I mean by goods is that at this stage, it will release the encryption keys for the startup disks for those virtual machines. So if anybody, as part of the boot flow, tries to mess A, tries to mess with the hardware type and move it to somewhere else, the attestation will fail and it will not release the encryption keys to start the VM. Likewise, you can take advantage of things like trusted launch, which is built into the Azure boot flow, where if, for example, someone tries to inject some kind of rootkit type code to subvert the startup process, it deals with it on a hashed basis. It will prevent the virtual machine from being started. You can also use this process with policy. Okay, so there are ways of setting confidential compute policy. And I've got some examples of how this works with containers that I'll show you in a bit. But there's a lot of things you can do there to specify various parameters and ensure cryptographically. I mean, it's things that you could potentially code in a script by querying the Azure control plane, but this is now able to be cryptographically proven and signed and delivered to you from the onboard system security processor. So if you think about the way this works, right, so because this is dependent on that, as like that kind of silicon level features, right, it's not something that's available ubiquitously today across the platform, right? And I guess, Richard, to your point, that's kind of one thing. AWS will obviously have claims that their Nitro gives them the same support across all their PaaS services. We view it slightly differently in that we have to, we're tied to that kind of hardware thing. So really, the way we do this, if you think we've done all the foundational work down here in terms of providing VMs, okay, so we have to start with the building blocks. Now, whilst you as a customer may not want to use VMs, brilliant, if you're in the cloud, nobody should really to do VMs for everything. But if you think all the services that sit up here, Cosmos, ABC, there's so many other services that live in Azure these days, but pretty much all of those are powered by virtual machines at the back end. So really what Azure's done is the kind of foundational engineering down here, and you can then see that start to bleed and spread out into the rest of the services. So IaaS, we currently have generally available the AMD and the Intel options. You'll see a limited preview for the NVIDIA capability. Intel on the far right, just to build and announce their TDX functionality. And the way I would think of this, if I were to just curse myself for putting so many builds into these slides. He says, yeah. So PDX is really where you start to see the playing field level between the two. There are some other functional differences. TDX obviously can be bind with some of the features and functionalities that are there with SGX, but notionally, Intel's new TDX capability gives you the ability to stand up an entire virtual machine on an Intel TDX CPU, the same as you can with AMD. Right. Containers, we've currently got GA, the ability to use SGX with AKS. We can do confidential AKS worker nodes, which I'll show you in a moment in the demo. So this is a set of worker nodes that are using the AMD technology under the hood. So any container you deploy to that automatically inherit that level of protection. Confidential ACI, which I'll demo as well, is now generally available. This has literally just gone out of preview and was announced GA build. This is for anybody who hasn't used ACI. So ACI is essentially Azure's serverless container platform. I think it's brilliant. I love it. It's really easy, right? You can take a container. You don't have to think about all that really complicated AKS stuff. You can just throw it to ACI and have ACI do its thing. ACI now supports a confidential SKU. And with that, which is the more interesting bit, it supports confidential compute policy. So you can do things, for example, like stopping people execing into containers. So, conceptually, you can have your black box, which is your container, and you can prove that nobody is able to exec into that, dump the memory from that container, do things to extract data from it. So it opens up a lot of interesting possibilities. And logically, that work that's done there for confidential ACI will extend out to AKS pods, confidential pods later, okay, which will then give you the ability to protect even against the admins of the AKS worker nodes themselves. So, with confidential AKS worker nodes today, if you can root onto the AKS worker node itself, you still can see the container in essentially in the open. In future, that won't be possible, and that's done with some quite clever nesting and masking technology that goes on in there. So that's the kind of foundational stuff. And to be honest, that's good, and that's all really cool kind of Azure core engineering. But really, for me, the really interesting stuff starts here. Yes. No, so in terms of feature capabilities, so in terms of GA, what's here today with the Intel SGX VMs, if you want to take advantage of the SGX technology on the silicon that your VM is deployed onto, you have to write your application in a specific way or use some various kind of third-party wrappers to be able to consume the SGX APIs. Yeah, so AMD is kind of really easy to stand up a VM and get going, and everything you put in there by default is protected, and it will end up the same way with the Intel TDX. I mean, I'm probably doing Intel a slight disservice there. It's kind of an oversimplification. They've also got a lot of quite clever attestation and kind of underpinnings that go with that around trust between processes and various other pieces. But as you can see, by doing all this foundational work down here, we now start to look to the top, right? So SQL, always encrypted with secure enclaves, has been out a little while now. This is where you can have individual tables or rows in the SQL database encrypted in use, so even the SQL administrator themselves can't see the data in plain text. It's like I said, if you want to see that in action, the mechanics video actually does quite a good job of explaining how that's laid out. Managed HSM and attestation inherit the technology that's used. They use confidential compute because logically, if you want to be able to attest and prove that a workload is confidential, it leverages a lot of that, the confidential technology in the first place to make that happen. Azure Virtual Desktop is currently in preview. And some of the people here I've worked with in this space before, but I always kind of make this point. If you are when you're doing cloud computing, right, you spend a lot of time kind of securing database servers and application servers, and you're doing the right things around making sure that data can't be exfiltrated, people can't log on to those servers, right? That's the right thing to do. The worst, dirtiest washing pot for all of the data in your organization is a user's desktop, right? Because what happens in reality, people take extracts of data from here, they'll do a bit of online data analysis here, and they'll take it all into the most evil tool in the world, which is Microsoft Excel. And they will, and every business in the world runs on Excel and PowerPoint. Microsoft are no different, I have to say. But from a data protection and privacy point of view, right, that's a real challenge, because whilst you're providing access to data and while you're managing that data in data management systems, you as the IT or compliance or security people have a good degree of control on what data is shown and generally where it goes. As soon as people can dump that out to a CSV file and do all kinds of things with it on their desktop, you're in a whole different world of pain. And if you go back to the point I made earlier about kind of aggregation of data, you've now got all that data being brought together, kind of mixed and washed. And I'm sure every organization does the right thing, but they use in terms of doing the best thing to secure those desktops. But on a traditional PC, you then have to start getting into doing quite complicated DLP, all of those kind of things, and you've got laptops wandering around and all that good stuff. If you're using a centralized solution like Azure Virtual Desktop, which is a Windows 11 virtual machine running in the cloud and just providing an RDP connection, so a thin screen and keyboard and mouse connection to it, you can now run that on a confidential VM. So you can always ensure that VM, wherever it is actually always wrapped on some of the SEV-SMP technology. So you can even start to get to the level of protection where even you can provide a degree of guarantee to regulators, for example, that if you're processing those workloads maybe outside of where they would normally be jurisdictionally allowed, you can start to build the argument that because it's encrypted, nobody can actually access into that VM without a very specific entitlement system. You've got to be entitled to RDP to it, right? And that's the ultimate connection in. We also added Azure Data Explorer. Yeah, I've certainly seen a lot of discussion around that thing. I mean, if you think about it, at least as far as I understand it, Windows 365 kind of hangs quite a lot on some of the work that's done in AVD, right? So you can see, and the way this is done really because services come along, we'll do some integration with confidential compute hardware because for a product team, they've got to make some minor changes to flip to use a different SKU and then do their validation, those kind of things. So like I said, we added Azure Data Explorer at build and confidential Databricks, right? And as I say, I'm not a Databricks expert, but from what I understand with Databricks is for Data Explorer, it covers the runners and all of the other ancillary bits and pieces that go with it. So also delivers you the ability to use customer managed key with that Azure Data Explorer. So as you see, if you watch to the right-hand side of that box over the next 6 to 18 months, you can kind of see where things are going. Azure's already kind of stated that really we think this is really the future of where we're going. If you think back to what I said around those kind of regulator queries, gentle cajoling, asks turning into foot stamping, yeah, that's going to happen. You can see why there's a driver to do that across the business. Sure. Yeah, I mean, it's a very popular ask. I mean, because you think about it, what do people run in Azure? They run applications and they run databases. So we've got fairly good coverage for SQL. There's Postgres, another very popular database there. So today, your options are really to run your application on ACI or AKS. But yeah, I mean, web apps would be a big win for this. Yeah. Yeah, I mean, unfortunately, I can't stand here and say it'll be here tomorrow, right? But you can see the intent. And I think even Mark Russinovich has stood up fairly publicly and said, look, this is where we see the future of Azure going. It's just, obviously, there are some logistical things. Now it's the cloud, it's someone else's computer, but that means there's actually quite a lot of underlying complexity to get some of that done. So if we were to look at what we have today with the AMD offering, this is literally something you can deploy today and underpins, for example, ACI and some of the AKS offerings. 2 types of SKU, and I would point this out because it's really easy to deploy it by accident or deploy the wrong one by accident. So D series, C for confidential, and then the tiny little bit that we forget and hide. The A there indicates it's AMD, right, which means it's running on an AMD processor, which is capable of SEV SMP. In the control plane, you can filter the SKUs for a VM, for example, and you can now filter to a confidential SKU. Currently support for Ubuntu, various flavors of Windows, obviously including Windows 11. And Red Hat 9.2s, since I've been at Microsoft, I think Red Hat's been the biggest ask from every customer I've been working with. You do need to pay attention to the versions. So obviously, whilst this is leveraged on doing some really clever stuff on the hardware, on the silicon itself, there are kernel drivers that are required to take advantage of some of this, which is why you just have to pay attention to the versions of these OSs. Right now, the AMD hardware is in 2 regions in the US, North and West Europe, and in the bottom right, you can see some of the smaller kind of regions that are coming later on. I'd love to be able to stand here now and say it'll be everywhere tomorrow. You just got to kind of bear in mind this does obviously involve life cycling, hardware, etc. But suffice to say, there's enough kind of engineering done on the back end that a lot of the other regions are being seeded with the correct types of hardware. It just requires a few bits of control plane engineering and the kind of underlying fabric of Azure to be realigned to accommodate it everywhere. I think it's fairly self-explanatory, but Azure's been doing stuff with confidential compute way back when, and you can see that's gone from just the initial offering of what we did with AMD, moved through to GPUs, and the whole kind of thing around AI was spotted fairly early with this, and that AI and ML type workloads for this really good kind of use case for confidential compute, and the work that's gone in with Intel recently with the TDX announcement. So anyway, I've talked loads. Has anyone got any questions before I show you a really boring plain text demo of what it actually looks like? Sure. Yeah. So right now there's 2 things to consider, right? So right now there is a small cost difference between the two. Okay. And there is a small performance penalty for data, and it does vary. I mean, and if you think about the reality of what happens under the hood to do encryption in use of this stuff, there's CPU cycles to do that. Some of that, I guess, in the CPU architecture is offloaded through dedicated processors and things like that. Right now, depending on the workload, it does vary, but we're talking single-digit performance difference, a percentage difference between the two. And I think we've said fairly publicly, our roadmap and heading towards it fairly well for the end of the year, getting that down to almost negligible between the two. Any other questions? Cool. Okay, now got to remember which window it's in. So I will apologize. This is a really plain text demo, but it kind of helps to show what it looks like. So if you can't read what's on the screen, let me know, and I can try and futz with it. I've tried to make it as visible as possible. So what we have is, now you get to watch all my typos in real time. No, not nose. So what we have is an AKS cluster I built earlier. It's a 3-node AKS cluster. So you'll see here, so AZUK 22 ACC. So these are all nodes that are built on AMD SEV-SMP hardware. And I'll go back to the command I typed earlier rather than make you all watch my typos. So all I'm doing here is I'm just basically querying for that node pool and the VM type that's running on it. So you'll see there it's running on a DC4, so D series VM, confidential for A for AMD, which means it's running on the SEV-SMP hardware. You can see actually I put all the commands in here. So what I have on here is a container, and all the container that's running on here is just a really simple. There's a really simple web server. So this CVM attest container here. So it's just literally a Python script, and what that CVM is doing is making a call to the attestation service. It's basically saying, "Hello, attestation service. Here's my proof of who I am. Tell me who I am." Okay. So it is this one. So what we're going to do now is we're just going to make a request to that container to have it show us its attestation data, which is what you'll see here in this delightfully formatted JSON payload it returns. So a couple of things. There is a guide on the Azure website that shows you how to go through and decode some of this. Some of it's split between data that Azure provide, and I'll show you that in a minute, and data that AMD provide. You can get things down even to like cryptographic proof of which firmware revision is running on the CPU. So in this case, you can see it's running against a shared attestation endpoint. You can stand your own up in your own tenant. It's fairly straightforward to do. Everything here that is prefixed with Azure VM is data that Azure provides back. So some interesting things to look at on here, if I put my glasses on. You'll see, for example, kernel debug enabled, false, right? So you can turn off through the configuration of this, the ability to attach kernel debuggers, to allow you to get in at a low level into that VM. This is the one really to query for here. So where I typically see this used is, firstly, this happens behind the scenes anyway when you boot your VM or your container. This happens transparently to you, and if it fails, it will just fail to start and log an entry in Log Analytics. One of the use cases I see this for quite often with customers is where they're doing they've got a confidential VM and they want that VM to crack open some secrets from somewhere else. Now, there's two things they can do. So that what they can actually do is have a key stored in a managed HSM. They can call to get the key from the managed HSM, and the managed HSM will only release it if it provides attestation data to say it is who it says it is. Okay, so it avoids anybody outside of the enclave sneaking snooping to get that encryption key to be able to open that encrypted blob store. Or the other way, which is maybe a bit more plain for this, but I've worked with some customers who are doing deployment pipelines for things. So when they go to deploy certain elements of an application or do something that's potentially a more privileged task within their deployment pipeline, because this is just a REST endpoint, they literally have a bit of their code call off like I'm doing here to query the to query those parameters, and all they're doing is they're filtering for what comes back. So they're able to prove that they're on a CVM. So if anybody tries to run that deployment pipeline on maybe a dev machine or something that isn't aligned to use confidential compute, they can have it bail out as part of that process. That's obviously not the only thing that's on here. So because this these are containers, this is an AKS worker engine, a worker node in this scenario. So I can actually deploy, and I will paste this command in because they always screw this up. So if I take, for example, Helm chart for any old container, so I can call 1, 2, 3. So what we're doing here is deploying WordPress, the famous demo application that everybody uses for everything because it's really simple. So this is now using Helm chart to deploy WordPress from the Azure Marketplace. And you will see Bob 1, 2, 3 WordPress is here. Now it can take a little while to spin up, but let's just try it. Took about a minute last time I did it, but so it's a lot because I'm doing it live. It will take a little longer, but you get the picture. What this is obviously doing is now starting up. It's got its Maria database. It's got all the stuff that underpins WordPress, but it's deployed 2 containers on a worker node, and it will respond any second now. Any second now. But essentially what that means is I've now taken an entirely unmodified container, I've thrown it onto an AKS cluster, and it's now running protected. So from a kind of threat scenario point of view, there you go. So from a threat scenario point of view, if you're using WordPress to host anything really sensitive, then you probably need to check your head. But what it really means is that if I were running, if this was a regulated application and I was running it on a public cloud provider like Azure, I could demonstrably prove to somebody that that container is protected whilst it's in use. Okay, so someone who at Microsoft, for example, who were able through whatever misfortunate stack of control failures was able to get onto the hypervisor, even if they dumped the memory contents of this container, all they're going to see is encrypted contents. And similarly, this is the other demo we have, which is really I'll just show you the code for this now. I will say my ARM coding is not particularly amazing, but what we're using here is confidential ACI. So this is using confidential ACI to take a Minecraft server, so just really a simple kind of community provided Minecraft server. What we're doing is we're deploying it onto confidential ACI with the default confidential compute policy, which will block things like the ability to exec to the container. And we're also tying it to use customer managed key. I would say because we're using the debug, the development policy, there are some things that it doesn't do. I'll put the link up later. This is actually a blog on the ACC blog that goes through how to do this. But you'll see this is essentially the JSON that will stand or already stood up my Minecraft container. Sorry, my Azure Key Vault. This is, so let's just create a new one, right? So let's call this 1, 2, 3 Bob, because Bob is everything. So what you'll see is that's the name of it. It's pulling in a custom. In this instance, I'm using an existing customer managed key, but you can obviously use a separate one. Because it's using the demo policy, it's not really doing a secure key release as part of this, but if you bake the right policy, you can have it do a secure key release for a managed HSM before it can open an external blob. And we're going to call it demo Bob. Okay, so that is now. I'm now going to just deploy it. Just try and save you watching my terrible typing. Nope. Did that in the wrong one. Sorry, wrong file. Throw away 1, 2, 3. Okay. Good. So now we're going to deploy that ACI container. Just literally very simple example of taking an entirely unmodified container and have it run up. So that will take a little while to do. It takes a couple of minutes. So here's one I prepared earlier. So this is essentially the same thing. So it's an ACI container. You can see, for example, it's using open source or community provided image. If you think back to what I said about being the ability to exec to the container, if you can see that. So the policy here will block me from having any access to be able to exec into that container. So at this point, I've got no ability really to crack that container open and pull data out of it. So this could be this is ultimately running as a headless process, running off and doing its thing. I could also complement this with doing some things with log analytics, for example, to send that to a very specific place or exclude types of data from it. You'll see, and to be honest, if anybody's got the Minecraft application on their iPhone, it will actually connect to this, but you'll see it's using the confidential SKU. There's a computed value or a hash of the confidential compute policy here. So this is what you set. It's a text parameter when you set it, where you control certain things like, for example, the ability to exec to the container. There are a number of other things that you can do there. And we're using custom managed key with this. So that is running. Let's just see if our other one has finished its thing. Yeah, so there you go. So that container that we just deployed is there. I would show you what it looks like to connect to it, but everybody's seen Minecraft, right? But this essentially is a useful way to demonstrate to your kids what it is you do at work. So this is my iPhone earlier connecting to it and just stood up and running. We kind of talked about the ADX piece. So I have got a metric ton of use cases here, but what I'll do is I'll pick a couple that I think are interesting, right? I mean, across different industries, yeah, sure. I don't think, to be honest, I don't think it would, unless you really turn the CPU down to within an inch of its life. Because if you think of most containers don't sit and run at 100% all day long. So, single percent performance overhead. I mean, I've never really seen any issues with doing it. And I actually, while I was messing around with this, I mean, I turned even the resources away. I mean, there is a point where you turn the resources down. It's more bound by memory, to be honest, than CPU in that use case anyway. Yeah, sure. How do you mean? Mhm. Yeah, I mean, so I guess the first thing is really this is supposed to prevent people actually having access to the data anyway. So you inherit all of the rest of the stuff that's on the stack in that kind of first slide we use. So all of the kind of standard protections that you get in Azure still apply. I guess the difference with this is here as a technical stop, literally a hard cryptographic stop of someone. If they had access to the underlying infrastructure, they're unable to pull the data out. I mean, there's not necessarily any specific enlightenments for Defender and things like that, if maybe that's what you're thinking of. But I mean, Yeah, I mean, there are some discussions open with those teams because, I mean, at the moment, obviously, we provide that logging data, which is picked up by Sentinel and things like that out there. But there's not necessarily anything to say, hey, confidential compute's been breached, because the point of it is you're not able to get to it in the first place. So across the kind of various use cases, I mean, just to call out a couple of interesting ones that I see. So retail is one that comes up a lot, and it's actually the same as a lot of the financial services use cases, where you've got lots of interested parties bringing data together, trying to do some analysis and then take back some kind of inference data out of it. Healthcare, I'm doing a lot of work in that space as well with people who actually are doing some really kind of worthwhile stuff. You know, if you look at genomics, cancer care, all those kind of things, where they're literally, if you could think about the point I made earlier about if you're trying to bring all those kind of disparate data sets together. I mean, I didn't really realize this until I started working on it. If you work in a healthcare environment, you know, even in the US, right, hospital A to hospital B to hospital C, they have to mask a whole bunch of data to be able to share anything, right? And if you're doing COVID analysis, which some of them are doing, you know, those kind of things, it got to the point where everything they're having to mask out basically makes the data worthless, because you're not able to, you know, you might see that somebody has a particular strain of something, but you're not able to see maybe some of the other indicators that they have because you have to mask it off. The kind of point of this is, and I'll show you a really quick view of what this looks like. You can bring it together inside a black box. It's almost like, I mean, maybe it's a trivial example, but if you think you're putting it in a black box, everybody's putting their hands in doing this, but all they get out is a result, not taking out all of the data that was in the box. And you know, and that's really important for those kind of drug development things. I mean, if you think all the stuff that happened during COVID, basically a lot of the issues around the privacy of this was just kind of, it's urgent, just stop, just do it. But you know, that's not a position that's really sustainable longer term. And certainly where they're getting into the genomics and cancer care space, there's, you know, some really clever stuff going on there. Likewise, government agencies collaborating with each other on data. I mean, there's an example in here. Sorry, just come back to it in a second. Difficult to do it in this view. This obviously isn't a government example, but it's a very similar principle, right? You know, this is RBC, you know, Royal Bank of Canada. So they want to be able to sell or take data from merchants and consumers, people they're working with. They might see that you're shopping at Domino's or whoever for delivering a pizza for an event. They might see that you really like pizza. It's probably going to get skewed if this is on your credit card. But they're able to do this kind of analysis with multiple parties in an enclave, but you'll see it's a bit small on here, but that kind of K1, K3, K1 is really where they have their own encryption keys for the data, right? The consumer, K2 key, doesn't have access to K3, so they can't pull the data sets out for the merchants, for example. They're only computed on in that enclave, but they're able to provide kind of referrals between the various agencies for you know, various offers and things like that. This happens. So Beekeeper is a really good example of this, right? This was from the healthcare space. So this is really that same model. They're taking all of that data, and in this example, they're using AKS with the confidential worker nodes. They're taking all that data, doing the analysis, and only sending data anonymized back out of the enclave, but they're able to analyze it inside the enclave in context with all of the background. This is to be honest, my favorite example of this, which was what I was trying to get to. So Scotiabank were involved in a program where they decided they were able to identify patterns of human trafficking through financial transactions, right? And they actually took a combination of financial transactions from various different financial providers. They can match it with things like missing persons data, you know, the CEOP, you know, the kind of the online database of exploited persons reports, all those kind of things. They can bring all that stuff together, do that analysis inside that enclave, but only provide the actionable insights back to the agencies that deal with those bits. And so, you know, quite an interesting way of doing this. Swift, anybody here who works in financial services is very familiar with Swift. This is working with, it's one of my colleagues that's been doing this, but working with Azure Machine Learning to do anomaly detection. I mean, if you think about it, Swift runs, you know, massive payment network for pretty much everything on the planet, except that bit up there that's no longer attached to Swift. they're using those kind of ML models to be able to take back, look for anomalies, look for potentially fraudulent transactions, and then take the right degree of actions to go and flag it. There's actually really, if you look at some of the materials from Build, there's a video that they put up from Swift where they talk about really how this is a game changer really for what they're able to do. This kind of plays into what we were talking about earlier. Right? There are So Cloud for Sovereignty, which is industry cloud program from Microsoft. So this is really around taking standard Azure technology, providing kind of usable elements to government entities. So, doing a lot of work with some EU governments around this, where they're able to define these sovereign landing zones. So this is kind of a combination of confidential compute wrapped with Azure policy, key vaults and reference architectures, RBAC and various configurations to give you a kind of stamped configuration for ensuring that workloads are protected from cloud providers, that they're always wrapped in encrypted VMs. In real terms, what this means is a policy that means you can only deploy confidential compute capacity, you can only deploy it in certain regions, and it always has to use key vault and CMK, etc. Kind of put together for that as a program. I think it's probably what two more I'll show you after this. I kind of appreciate we're running a little bit long. So Proximus, whose logo got dropped off this for some reason. Belgian ISP, right? So they are a 5G network carrier. They have a lot of obligations to meet under GDPR. They're looking to confidential compute and are using AKS as a way of demonstrating that they're able to segregate people's data from a US-owned cloud provider, but have it processed in region with them in control of the data that's held within it. And I will just show you this one example, because I think this is quite a good example of what some organizations are doing with the SEV SMP technology. So BMW are running traditional Active Directory domain controllers, but because they've got them on AMD SEV SMP VMs, right, the Windows OS itself already does things like address space randomization and all those kind of things, but it really means they're able to wrap an extra layer of protection around those domain controllers. And if you think about it, those domain controllers really do hold the keys to the kingdom for everything. If you think about all those kind of golden ticket type attacks that you can do, this is a way of them ensuring that they've got a further layer of wrap and protection around their workloads that are running there. Similar sort of story for Bosch. That's not really worthwhile. But where I wanted to wrap up is really, like I said, this is going to end up, regardless of whatever I say, I think we'll end up being the technology that all public cloud providers use, right? And there are benefits all around for that happening. And I think it's definitely going to move from a nice to have to a, you're going to have to start doing it. Some links there for the general landing pages. I would definitely check out the blog. That's got the specific steps to go and reproduce my Minecraft example if you need to demonstrate to your kids what it is you do for a living. ACC Docs also has got some really good quick starts for everything from deploying a confidential VM all the way through to some of the more kind of complicated machine learning pieces that you can put together. But that's it. Thanks very much. More than happy to take questions. I'll just stop the recording, shall I?